we're going to start our new topic of sequences. There's a few different kinds of sequences, but we're going to start with the easiest kind, which is good. We're going to start with arithmetic sequences. But first, let's just talk about some of the language around it and some of the notation so you get familiar with it. So you can see here that I've got U1, U2, U3, U4. That's just the little notations that we're going to use to say this is the first term, second term, third term, fourth term, blah, blah, blah. So if I wanted to say what 5 was, well, I'd count up 1, 2, 3, 4, 5. So 5 is the fifth term. So I'd actually write U5. That's got nothing to do with the fact that it is 5. It's just a coincidence that it happens to be. So I don't know if you know this pattern of numbers, but if you don't know it already, it's probably a good one to learn. So you might be able to pick the pattern, whether you know it or not. I might give you a second to think about how these numbers are connected. So this is a famous series of numbers called Fibonacci. So the Fibonacci sequence starts off with a 1 and a 1, and then from then on, all you do is add the previous two numbers together. So 2 is 1 plus 1. 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, and etc., etc. So that's just a good pattern to know because it'll come up a lot in our textbooks and future maths things. So an arithmetic sequence. This is the kind of sequence where you're always adding or subtracting. So geometric sequences are about multiplying and dividing, but arithmetic sequences are always about adding and subtracting. So what I'm going to do is just look at the pattern. So how do I get from 3 to 5? How do I get from 7 to 11, etc., etc.? Now, if this is an arithmetic sequence, then all of these will be the same. And they are. You can see that you're always just adding 4. Every time I add 4, and so this is an arithmetic sequence. Same thing here. So let's have a look at how we get from one number to another, and hopefully you can easily see that we're just subtracting 4 each time. So either you're adding or subtracting. So this bit's easy, and there's a way that you can come up with a rule using this information, but it's not always that helpful. So this is what we can call, let me get my other pen back out. So we can call this a recursive rule. So a recursive rule is when you have to know the previous term to get the next one. So I might say n minus 1 plus 4 equals n. Something like that. So what I'm saying really here is that the previous term, so if this is n, then the one before it, you just add 4 to it and you get the number that you want, right? So we're not really going to make you write these types of things at the moment, but most people come up with recursive rules when they look at patterns. They would just look at something like this and say, oh, you add 4 every time. But that's not actually a very helpful rule because I'm not starting at 0 and I'm not starting at 1. So it's not, if I was starting at 0 and I went 4, 8, 12, 16, blah, 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 then it would actually be quite helpful, but it's not when I'm starting on a weird number. Or I'm starting at 9 and going back by 4s. A rule like that isn't going to help you. If I said what is the 76th term, then a recursive rule isn't going to help because you must know the previous term to know the next one. So what we're going to do is come up with a rule for the nth term. So we want to come up with an algebraic rule that tells us how to find any term we like, and we don't need to know the previous one to get it. So it should be easy enough here to find our pattern. This one's relatively simple as well. We're just adding 5 every time. So what I want to do now is come up with a rule for how I could say this algebraically. So I want to say that the nth term, so there are different ways to write this. I'm used to using an n and the book is using a u, but sometimes it uses an n. So the book is writing it as in un, so the nth term. So yeah, let's just maybe stick to that kind of writing. If I accidentally write something else at some point, actually that means I should change this, shouldn't I? So un minus 1 plus 4 equals un. Okay, so let's maybe stick to their way of writing it. Okay, so over here, what I'm doing is I'm adding 5 every time, but I want to come up with a rule that shows me how to do that. So what I'd like you to do is pause the video and see if you can come up with a rule, and then I'm going to show you what it is. So hopefully you paused and you've had a chance to think, but well, first of all, I'll just give you the rule. So this one is 5n plus 2, and I'll tell you how you can come up with that in a really easy way. So 5n plus 2, right? So if I just pick the third term, so I would do 5 times 3 is 15 plus 2 is 17. It works. Why don't I try this one? So this is the fifth term, so 5 times 5 is 25, plus 2 is 27. It works really well. But if you want to know how to get this, well, guess what? You may have noticed that this number here is this number here. So the first thing that you're going to do is say whatever number is attached to n is whatever I'm going up by, and then you can easily work this bit out. So if you just say, well, okay, I'm going up by 5 every time, so it's going to be 5 times whatever plus something, well, just start with the first term. That's easy. So 5 times 1 is 5, and then I need another 2 to get to 7. And then you can just test it with a few different terms to make sure it works. So let's do exactly the same thing here. So what are we going up by? Well, we're going up by 4s. I'm sure you can see. Oh, I've written 7 instead of 17. That's not great, is it? All right, so adding 4 every time. So again, I'd like you to pause the video for a second and try and come up with your own rule, and then I'll write it down. All right, so the nth term, I'm again going to use the number that I was going up by, so it's definitely going to start with 4. So it's going to be 4n, and then I need to decide if this is 1, 4 times 1 is 4, and I need to get here. Well, this time I'm subtracting because I had to get down to a 1. So I'm going to do 4n minus 3, and then I'm just going to check something else and make sure it works. So let's try this one. This is the third term, so 4 times 3 is 12, 12 minus 3 is 9. Fantastic, it works. All right, same thing here. I'm sure you can see what's going on between these, that we're just going up by 2s every time. So again, have a think about what the rule's going to be. So the nth term, well, I'm going up by 2 each time, so 2n. Then I want to think about what I'm adding. So 2 times 1 is 2 plus what? Well, 5. And then I'm going to check one over here. So the fifth term is 15. So 2 times 5 is 10 plus 5 is 15. Fantastic, it works. All right, let's do one more. What's going on here? Well, we're minusing 3 each time. So this one's a little bit different to all the others because they were adding. So same thing. So u to the power of n. Have a think about what it might be. So you might know that if we put 2, 4, and 5 in front, this time we're going to put minus 3 in front. So negative 3n. And then again, I just say whatever I need to do to get up to this. So negative 3 times 1 is negative 3. Plus what to get to 12? Well, that's going to be 15. And then I'm going to try it for maybe the fifth term. So negative 3 times 5 is negative 15. Negative 15 plus 15 is 0. So it works. All right, so this is about arithmetic sequences. You're not coming up with recursive rules. We're coming up with the nth term. All right, if you need some extra help, then please let me know. But that is all for today. Good luck.